So the last lesson was all about vocabulary, and this lesson is all about computation, the actual doing of math. So make sure that you have that hat on today where you're thinking about computation and process and things like that. So we're going to multiply fractions, including negative fractions and including variables. So first, we just want to talk about what does it mean to multiply fractions. So if you were asked to do 1/2 times 1/4, another way to think of that is 1/2 of 1/4. So if I took 1/2 and I shaded in 1/2 of the design, right? This would be 1/2 of the design. And if I did 1/2 in that direction and I did 1/4 in the other direction and I did 1/2 of 1/4, you'd get this one little overlapping region here, which would be your answer to the problem. 1/2 times 1/4 is 1 out of 1, 2, 3, 4, 5, 6, 7, 8 sections. 1/2 times 1/4 equals 1/8. And in order to do that, you multiply the numerators and multiply the denominators. That's it. It's that simple. If you look at the diagram that's over here, 1/3 times 1/3, or what's 1/3 of 1/3? Well, if I shade 1/3 of the diagram in this direction, and I shade 1/3 of the diagram in this direction, you have this small overlapping region here, which is one section out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 1/3 times 1/3, or we went 1/3 in this direction and we went 1/3 in this direction, is equal to 1/9. So obviously this is going to be the most basic part, or the most simple, and then we're just going to step it up a couple notches from there. So we're going to look at multiplying negative fractions and mixed numbers. So let's start with just the fractions. 3/4 times -10/9. Now, you've probably seen before that you can simplify an answer, but we're also going to look at how you can simplify the problem or the work before you get to the answer. So we're going to look and see if there's any numbers that are in the numerator that share something in common with a number in the denominator. And for example, we've got a 3 in the numerator and we've got a 9 in the denominator. And I noticed that both of those numbers can be divided by 3. So if I do 3 divided by 3 and get 1, and 9 divided by 3 and get 3, I've just simplified the fraction 3/9 down to 1/3. In the other direction, 4 and 10 can both be divided by 2. So 4 divided by 2 is 2, and -10 divided by 2 is -5. So for all intents and purposes, I simplified -10 over 4 to -5 over 2. And now I can multiply what's left over. In the numerator, I've got 1 times -5, which is -5. And in the denominator, I've got 2 times 3, which is 6. And I would have an answer that's already in lowest terms. I don't need to simplify my answer anymore because I'm simplifying the problem. And that is the expectation. 7th grade, not 5th or 6th. We are all going to be simplifying the problem instead of simplifying the answer. And this guarantees us that the answer is always in lowest terms if we do all the simplifying before. Now, what's the benefit? The benefit here is that I'm only working with numbers, in this case, -10 and lower. I don't have anything in the 30s. I don't have anything in the 60s. I don't have to deal with what does 30 have in common with 36. I'm looking at very small numbers, which is a huge benefit to you working with much smaller numbers. So we're going to look next at 2 mixed numbers that are getting multiplied. I didn't mention up here that I did a positive number times a negative number and the signs were different, and that's why my answer was negative. Down here, I've got a negative times a negative, and I know that means that my answer is going to be positive because the signs are the same, but just wanted to mention that. So I'm going to change both of these into fractions, and they're going to be improper fractions because you cannot multiply mixed numbers. I'm going to make that little note over here. Cannot multiply mixed numbers. It doesn't work that way. You do not get a correct answer. So first thing we're going to do is rename them. So -1 5/6 is going to be -11/6 times Negative 2 and 1/7. 7 times 2 is 14, plus the 1 is 15/7, also negative. So a negative times a negative. The other thing that I want to mention here is that there's no multiplication sign in the original problem. We've just got a number bumped up against a parenthesis, which tells us it's multiplication. Those other symbols are negatives, and I know that because the second one is in parentheses. The first one does not have to be in parentheses, but because there is no operation separating them and the first number is bumped up against the parentheses, I know it's multiplication. I'm going to look and see if there's any number in the numerator that has anything in common with the numbers in the denominators. And I don't see anything with the 11 and the 7. I don't see anything with the 11 and the 6, but I do notice that 6 and negative 15 can both be divided by 3. So 6 divided by 3 is 2. Negative 15 divided by 3 is negative 5. And that's it. So then I'm going to cross multiply. Negative 11, sorry, I apologize, not cross multiply. I'm going to multiply my numerators. So negative 11 times negative 5 is positive 55. And 2 times 7 is 14. And you're done. That's the answer. And you know that the answer is in lowest terms because you simplified the problem before you got to an answer. And so that's the whole problem. And you don't have to go back to a mixed number. This answer is perfectly acceptable. If you were going to if you're going to walk into like Home Depot and ask for, them to cut something, you wouldn't ask for 55/14 of a foot. You would want to convert that into a more usable number. But as far as math class goes, that answer is perfectly acceptable. All right. So now we've got some with variables, and we can cancel and simplify variables the same way that we can cancel and simplify numbers. So I'm going to look first, any numbers on the top that have anything in common with numbers on the bottom. And I saw that 3 and 6 are both divisible by 3. So I did 3 divided by 3 is 1, 6 divided by 3 is 2. And then I noticed I now have a 2 in the numerator and a 2 in the denominator. And they both simplify to 1 because 2 divided by 2 is 1 in both cases. I also have an x in the numerator, but no x's in the denominator, so I'm going to leave it alone. I have a z in the numerator and a z in the denominator, so I'm going to cancel those both out. I have a w and a y in the denominator, but nothing matching in the numerator. So all I have to do now is multiply everything left in the numerator. So I've got a 1, I've got an x, and I've got another 1. In the denominator, I've got a y, I've got a 1, and I've got a z. And you don't have to write this middle step, but collecting the things you have left is sometimes very helpful. So 1 times x times 1 is just x. Y times 1 times z is just yz, and that would be your answer. You would have nothing else left. Sometimes the variables cancel out completely, and sometimes they don't. So if we look at the question next to that, we notice first off that there's a negative sign and a negative sign, which means we know the answer is going to come out positive. I'm going to look at the numbers first. I've got a negative 2 with a 4. So negative 2 and 4 are both divisible by 2. So this will be negative 1, and 4 divided by 2 is 2. I'm then going to switch over to looking at my variables. I have an x in the numerator and an x squared in the denominator. Now remember that x squared really means that you've got x times x. So I can cancel, or I can say x divided by x is 1 and x divided by this x is 1, leaving me with a single x in the denominator and none in the numerator. I still have a y up here. I still have a z down here, but none of them have a match. So I've got a negative y times, and I've still got a negative 1. Notice the two negatives still represented. I've got a 2, I've got a z, and I've got a single x left over. I'm just collecting what I have left in the numerator, collecting what I have left in the denominator. The negative times the negative is positive, and y times 1 is y. 2 times z times x, that's literally what you're going to write, 2zx, and you would be done. So letters can cancel or simplify the same way as numbers, 1 from the numerator and 1 from the denominator. If you have something like x squared, feel free to write it out as x times x, and that way you'll know what ones that you can cancel or simplify. What if there are more than 2 fractions? So for this example, we have 3 fractions, and you can do the exact same system. You can pick any one number from the numerator to partner with one number from the denominator if they have something in common. And I noticed that the 24 and the 8 are both divisible by 8. So 8 divided by 8 is 1, and 24 divided by 8 is 3. They do not have to be next to each other. They do not have to be perfectly diagonal each other, as long as one is a numerator and one is a denominator. The next one that I noticed was the 15 and the 25 are both divisible by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. And I have to say, guys, at 41 years old and 20 years of teaching, I still will tell myself out loud what I'm doing. I will say 15 divided by 5 and then write the 3. I will say 25 divided by 5 and then write the 5 to make sure I'm dividing them by the same number. I see one last pair, and it's this 3 that I have in my handwriting on the top with this 9 in the center on the bottom, and 3 and 9 are both divisible by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3, and now I can start collecting, because I only have a 1, and a 5 in the numerator, a 3, and a 1 in the denominator. There's nothing left in common, which would give me 5/9 as a final answer. Now I'm going back through here, and I noticed from the beginning that I had a little negative sign floating here at the beginning, and it is the only one. It is the only negative sign, but it really was never assigned to a numerator or denominator. So you can pick. You can either leave it out in front or you can assign it to the numerator. Most people assign it to the numerator, but you do need to double check. The original problem only had one negative, so the answer is also negative. All right. Last but not least is the same concept, but you might be asked to evaluate an expression, and we might give you the values of x, y, and z and then ask you to do something, in this case to x and y. In this case, it uses x and z. First thing we have to do is show that substitution. We take out the x and we substitute 3/8 in its place. It's multiplication because there's no symbol between the x and the y, and y is worth -2 and 2/9. And I remember from the front that mixed numbers are not going to work. So I'm going to rename this 3/8 times 9 times 2 is 18, plus the extra 2 in the numerator is going to be -29. So I've got a fraction times a fraction. And I noticed 3 and 9 both are divisible by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. 8 and 20. While 8 does not go into 20, 8 and 20 are both divisible by 4. So 8 divided by 4 is 2. -20 divided by 4 is -5. I'm not going to write that middle step because I don't expect that you're going to always need to write that middle step. You can if it helps, though. 1 times -5 is -5. And in the denominator, 2 times 3 is 6. And you would be done. And your answer, is in lowest terms because you put the problem in lowest terms. Another strategy you'll notice that I'm using is different colors. When I simplify each step in a different color so that I can always double check it in case I look at my answer key on the homework and I go, ooh, oh no, I got this one wrong. I can go back and look at the things I simplified and say, did I simplify the 8 and the -20 correctly? Did I simplify the 3 and the 3 and the 9 correctly? And so color coding really helps keep me organized. You could also use highlighters as another option. The last one is 5xz. So the first thing I'll do is I will substitute 5 times x is worth 3/8 times, and then z is worth -4/15. And because the negative is up with the 4, you can leave it in parentheses or not in parentheses, and it would still work fine. But if your negative sign was out in front of the fraction bar, you would definitely want the parentheses there. The only renaming I have to do is the whole number. And we saw in the last unit that whole numbers can be written as fractions by putting them over 1. So 5/1 times 3/8 times -4/15. And now you can see all of your numerators, you can see all of your denominators, and start looking for simplifying options. The 5 and the 15 are both divisible by 5. So 5 divided by 5 is 1, and 15 divided by 5 is 3. I can also see that 8 and -4 are divisible by 4. So 8 divided by 4 is 2. -4 divided by 4 is -1. Oh, I noticed I created one more. When I got a 3 as a result down here, I can partner it with the 3 up in the top. So 3 divided by 3 is 1, and then this 3 divided by 3 is 1, leaving me with not a whole lot left to multiply. I'm going to do across the top, 1 times 1 times -1. That's an odd amount of negatives, so it's -1. And 1 times 2 times 1 is just -1/2. It's not a lot of work, but because I simplified the problem, I didn't have to simplify the answer. So please make sure that when you're doing the video check-in, that when you're doing the homework, the 7th grade expectation is that you are simplifying the problem, both numbers and variables, before you do the multiplication. Your answer should already come out in lowest terms, and that if you are simplifying something that has variables, that the variables can cancel just like numbers. Can't wait to see you guys in class. Have a great day.